there.
On that TV.
Those are critical infrastructure dashboards. We use Grafana, it's called, which is like a free open source tool that will pull data from basically any data source you give credentials to, and then you can write queries against it. It's just SQL. Yeah, dashboards are easy. It's just so dashboards, when the data is in the right format, are always easy to create, because all it is you write some query, and then that results in some table, which is just like an X by Y table of like, here's our fields, here's the data. And once you have that formatted correctly, to put a visualization on top of it is really simple.
So what's your visualization?
So we like that's Grafana, so you can do all kinds of stuff. So they have that like speedometer thing, which we use for like the CPU and stuff, which is we have a max of 100%. It goes up, so pie chart type deal. Periscope has a bunch. They have bar charts and stack bar charts and line charts and all kinds of things. If you're interested, you can look at like D3 is the most commonly used chart.js thing. Chart.js though is becoming more popular. That's like what we're building some of the new stuff on. It's probably built on top of D3 though. D3's been around forever. That stuff is built on D3. Periscope's built on D3. But yeah, the dashboard itself, the visualization's easy usually, because you usually have some software where you're just like, okay, here's the query, here's the data set, and then it just turns it into visualization. Yeah.
Everybody makes them. They're just like, we love to see data.
Yeah. Yeah, most of the time it doesn't mean anything. Yeah, the hard part with creating dashboards is getting the data into the right format, the right structure, making sure you have the right data to be able to show something that's useful, and thinking about whether the visualization actually shows you something that matters or not. Like the things we try to limit it because you only have so much screen space. In fact, like even right now, it's rotating between like our beta and our legacy because we ran out of room. But you want to like really think about what you're putting up there, because if you put too much stuff, nobody pays attention to it. If you have stuff that you know you need to ignore, nobody pays attention to it. If you have stuff that is just not useful pieces of information, nobody pays attention to it. So it's got to be like the very small, limited set of things that you actually really care about. So like if our CPU spikes to 90%, we have a problem. Like we really need to know about that. If our memory runs out, if we have lots of pods that are crashing over and over again, all those things are problems. And so that's what shows up on that dashboard. Over there, for the comms team, we do it in Periscope, which is just a little prettier, but costs a lot more. And they show things like how our integration runs are doing, and how audiences are doing in terms of updating, and how messages are doing in terms of actually going out, and how many of them are getting carrier filtered. Are you guys familiar with that term? Carrier filtering is when you send out a text message. At the moment, carriers, so Verizon, AT&T, etc., have the right to refuse service to anything that they think is spam, which a lot of times is us. We don't intend to be spammy, but we might be sending out, 40,000 people get accepted to the University of Arizona. We're going to send out 40,000 text messages. It looks like spam. It's actually incredibly useful information, but they will potentially mark us as a spammer because we're sending the same message to a whole bunch of people.
So the receiver won't get it? Or?
So the receiver won't get it in some cases. So a lot of times what will happen is they filter. So we've done things to mitigate this. One is if we send things through short codes, then we can mitigate a lot of it. They don't care as much about spamming if you use short codes, which is why you get things like from Chipotle or whatever that are on the 6-digit numbers instead of like a 4-digit number. That's what a short code is. It's just a short number. Those cost a lot of money though. They're like $12,000 a year or something. So we are trying to move away from that. Actually, 800 numbers actually let you do some similar functionality. We'll get into all this stuff at some point, but one of the ways that we can mitigate it is by sending through short codes. The problem with short codes is long codes, regular phone numbers, you can send messages to people without having them opt in. You actually don't have to do this, but schools are very concerned about this. So if we send a long code message, we allow people to opt out. So we'll send you the message, But immediately before the first message we send to you, we say, hey, opt out by texting stop, right? Short codes, you can't do that. I can't send you a message until you've explicitly opted in through something else. So like I could send you a long code message, like a message to a phone number with a long code phone number saying, hey, will you opt in? And then they can say yes, and then I can start sending through short code. But it might have gotten carrier filtered because I might have sent that message to 40,000 people, so that's not particularly useful. And so
that policy, it seems like, what's the difference? It's still coming from a number.
It's money.
Yeah.
Because the carriers now have a specific format where they can say, I can stop spam, and that means that people who want to spam, like us, we're not actually trying to spam, but there are lots of people who are trying to actually spam, but they're not stopping those people from spamming, they're just saying, pay us lots of money to spam. And so that's really what it's about. But the outbound piece of it, because then regulators, the government, decided, well, we can't just let you spam people, even though you're giving a different method for spamming. We still don't want you just spamming the crap out of people, and we know you're using these short codes to spam people. So what we're going to say is they have to opt in first. You have to have an explicit piece of data that says they opted in before you can send them a message on short code. Now, it's very poorly adjudicated. Like, you almost never actually go to court about this. We probably could get away with it for what we do, but we're not trying to risk that. So we do wait to get some sort of an indicator that we're okay to send them things through short code messaging, which might just mean that we've received an inbound message from you before on a long code. So it might not be an explicit, hey, you can send me messages, but like, whoa, so like it's a pretty reasonable, right? Like, I sent you a message and you responded with something that's not stop. You're probably okay with receiving messages from us, right? And so that's the ideas, and from what our reps tell us, that's okay. All it means is we're not explicitly sending you a message that says, hey, will you allow us to send you messages from a short code on a long code, which is spam in and of itself. We're just sending you a message on a long code like, hey, your admissions application isn't complete, please finish it. And if you respond, I don't know how to do that, then we mark you as, okay, they're cool with receiving text from us. Like, it's not, I don't think it's very nefarious. It's just, we're trying to stop we're just trying to give some indicator that it's okay for us to do that, which then stops carrier filtering. Carrier filtering got really bad this year. The carriers started to get super rigid about who they would, what their computer algorithms were doing in terms of stopping spamming. It got to the point that, like, in some cases, like 30% of our messages were getting carrier filtered. So we had to re-implement things, and the way we did that was, it's so silly too. Security and like these types of prevention methods, they just don't work, because anybody with a brain is going to get right around them in 10 seconds, especially if you're already in the place where like you're about to be. Anyway, so we started getting carrier filtered like crazy, and we can't have that because we're trying to give students very like time specific critical pieces of information. Like, you don't finish your FAFSA right now, you're not going to get any money. You're not going to go to college, right? Like, we're trying to help people, and the carriers are stopping us. And I get it, because what they're really trying to stop are, like, the nonsense spam texts that you guys all end up getting. But we're trying to actually help people, and they won't let us. So when they do that, there's a very simple workaround, because all of this stuff is programmatic. So we know when we've gotten carrier filtered. So what we do is we say, as soon as we get carrier filtered, swap the phone number. Just go get a new one and do it again.
As in, like, you guys get a new one?
We get a new one for that advisor or entity, the department, whoever, and we say, okay, send that, if it got carrier filtered, send the message again, just use a different phone number. And so it sends it again until that number gets carrier filtered, and then we just say, go get another one and try again, and then go get another one and try again, and so we just push right past it. So it's like, what? What are we even doing? Just stop it. Just wasting money. Which again does make the carriers make money off of that, because we're buying a phone number for each time that we have to do that. And it also pushes us towards the short codes, which they want us to buy, which is the $12,000 piece. And when we buy short codes, we share short codes, and because of our volume and stuff, we have to have enough short codes. So we actually have 5 short codes that we use. One we use for auto responses across institutions. So somebody could say like go IWU or go Hope or whatever to the short code, and they'll get back a response, which will put them into an audience, and they start communicating with that particular institution. One we use for testing, because we have to have something to actually test short codes and make sure that they work, that's not out there in the real world. And then we have 3 that we share across institutions, and the way that we share them, we have to keep track of like which short code corresponds to which department for each student, and that ends up being like each student can interact with up to 3 entities in our system, which could be one department at 3 different schools. It could be 3 departments at one school. But once we run out of those, then we have to all other communications to that student have to be through a long code, which kind of sucks. Yeah, because there's no other way for us to keep the thread clean, right?
Is there no instant message like solution to this?
So we have in-app messaging, if that's what you mean by that.
Yeah.
But you gotta have the app.
You have to get the app. So we have to get people to go into the app, which the initial solution to that was, okay, well, let's just go with a different approach, which is, hey, when we send a message, let's truncate it at 120 characters and then say, read more in the app. And then they click on it and incentivize people to get in the app.
Yeah.
But schools are like, nah, fuck that, because I don't want to take the potential risk that somebody won't go download an app and talk to us. So that's out. So we'd never get people to go into the app. So maybe 2% of our communications happen in app. But yeah, it's much better, because then it's a dedicated means of communication that's happening between the... Yeah, and it does take the spam piece out of it, which is very much like there's a dedicated line now between you and your student. So we try to preach best practices to our clients. They just aren't hearing it yet, because they don't understand it yet, because most of our clients are just now moving. I mean, we're the first, in many cases, probably 60% of the cases, we're the first mobile-based communication strategy they've ever used as an institution. They've never texted a student before. They've certainly never used in-app messaging before. They understand email and they understand mailing.
Email.
And that's
email,
it. Yeah. They understand calling, mailing things old school, and email, none of which does anybody read anymore. They're gone. Right? So that's what we're trying to provide in terms of help. But it's very difficult to create that cultural change. It's also difficult because the early days, and this is both internal and external, the in-app messaging stuff that we had was very much hacked together, because it was like we do with many things. We sold it and then we built it. So it didn't exist, and then it needed to exist in three weeks. Like we went literally from having no in-app messaging to having in-app messaging in 3 weeks, which is like...
So what kind of, like, are you guys just like at the sales pitch giving them like a wireframe or a mock-up or something?
They're showing them PowerPoint slides with
like things that are not existing.
Yeah, that don't exist. Which is like, it's the worst, but it is a thing that you do need to do early on, but it can be done much better, right? So the way that they've done it here is based on how they used to do it 10 years ago, 15 years ago at Blackboard, which is like people didn't know anything about technology, and so you show them a PowerPoint slide, and then they buy into the idea, and then you build it for them 8 months later, because that's how technology used to roll out, because it was a thing that they had to get a CD and then put it in, and like, so you have the time to build something in 6 months. But nowadays, the expectation with like SaaS is, well, it exists there, we bought it, I want it tomorrow, right? And like, so that strategy doesn't work as well. The way that strategy could work is, what we're going to do is we're going to try to sell this, and we're going to show the mock-ups and PowerPoint slides, and we're going to see, and really what you're doing is getting market interest and feedback. And if we can sell this to 3 people, then we know that this is a valuable good. And if we lose those 3 people, like because we don't actually make it live in time, then okay, whatever, we know that this is a valuable product and we can take it and go to market. Like, and it's unfortunate, and like you don't really want to do that, but how else do you know if the thing you're building is worth the money? Because you can try and talk to people, but until you start getting dollars, behavioral, actual, like you don't know that you could actually sell it. They might be interested in it, but can you get them to go to their procurement offices and get you money? Yeah.
It's like a Dropbox effect.
Yeah. Yeah. So when we get that, so when we built that originally, it was a very hacky solution, so it wasn't done right. And by right, largely it means we didn't use, well, lots of things were wrong with it, but the biggest thing was that we didn't use WebSockets. WebSockets are a relatively new technology. I mean, it's been around for like 7 years now, but really only started to get more popular in the last 4 or so. Um, WebSockets are the thing. I think we talked about this before, but so you don't have to do the polling, the long polling, which is like right now every 30 seconds on the advisor side and the student side. Actually, we changed this because so originally the way that we had to set it up was every 30 seconds. If you have the app open, we would go check to see if there was a new message. It causes a couple of struggles. One of which is, well, that's kind of slow because 30 seconds, I send it and you have to wait 30 seconds. That's not what we're used to. You're expecting it to go right now. And so it loses confidence because when you're training people and you show them this and they're expecting a modern day in-app messaging experience and it doesn't show up for 30 seconds, they're like, what the hell is going on? Mm-hmm. The other problem with that is you end up you DDoS yourself. So if enough people have the app open, then every 30 seconds they're all making a request for new messages, right? So that's a lot more traffic than we're actually handling, right? Because there's maybe 5,000 people that are on the app, but most of the time they're not actually doing anything. They're just kind of like looking at stuff. And so now, though, every 30 seconds you're making 5,000 requests to the server, and you weren't expecting that, and so the server potentially drops off. And at the time when we were we actually did this to ourselves. The ops infrastructure that we had didn't scale in any way, and so we just took the entire production server down, and there was only one of them, and we just took the whole thing down, and then we'd have to bring it back up. So at that point, we moved to another hacky solution because now that, and this is the problem, once it exists, you can't just take it away. So, and you can't take it away from a moment and then bring back a new one. So you have to keep it going. So what we did is we did another hacky solution. We used push notifications. You guys are familiar probably on your home screen. You see the push notifications. Also in the browser now, you'll see the push notification come across the top of the screen. Mm-hmm. The nice thing about that is instead of polling, you're now pushing. So you push to Google or whoever, and then they send to the device, whether the computer or the phone, hey, you have some new information. So we used that as a mechanism for triggering in our software that, hey, you need to go look up new information. So instead of doing it every 30 seconds, we now just do it when you have a message. That has its own set of issues, though, including that because that, especially in the desktop browser, is a relatively new thing. When advisors were using our desktop app, the web app, there have been versions of Chrome that push notification got broken on. They broke their own push notifications, but that broke our software, and that lost confidence in clients. So the in-app messaging piece of it, including Browser Support, which is a huge pain holdout, we went to them a little bit early in this process because they really wanted to have this in-app messaging thing. And we're like, you need to do this. And they, in that particular week, saw a drop-off in responses from students, largely because of this in-app push notification hackiness that we had done was causing it to not actually work correctly. So now they think that in-app messaging doesn't work and nobody responds to it, when that's not what it is, that it was broken, but they won't try again because now they're fearful of it. Yeah. So it's gone in instead.
So the only way it's new clients in to
yeah.
get them to use it?
Yeah, so it's new clients and then careful conversations with old clients, and then the better you can communicate, the better off you are, and that's where integrity becomes so important in business, is if you're honest with people about what's going on, which unfortunately we have not been in the past. But if you're honest with people about what's going on, then they're like, oh, I see what's happening. You communicated well with me that the problem was that there was a bug in the system, and that's why it's not working. And so, yeah, I get why if we try again, there's a higher probability that it works out. And I also understand that we would want to do that because of this carrier filtering issue and other things, right? But we don't communicate, or we haven't in the past communicated all that well with our clients about this stuff. And in that particular case, we had other issues with the client at the time, and so I'm saying we are very much pushed against these things. But it is still ultimately our responsibility as a company and as an organization. We decided not to tell them there was a bug in our system because there had been other bugs in our system that they were complaining about, and we didn't want them to lose confidence in the entire thing. So it sucks. This is not these are things that you don't think about in business and you don't want to be a reality. But especially in a startup where you're trying to make things and you don't have that name for yourself, it's hard. There becomes a point where it's like, oh, the software that we have is great and everybody wants it and we've got the value there and people are paying into it. And then we can go to clients that are like that and be like, well, whatever, like we are the solution that exists in the field. So if you don't like that there was a bug in our system for a week, go find something else. There's nothing else. So, and so you can kind of like back off and be more reasonable in your communications and stuff. Until you get there, though, it's really hard, and it really doesn't suck. Like that's not what you want to do. Probably shouldn't be recording this for YouTube, but it's real life, and I mean, if somebody comes across this, like that's it's an unfortunate reality of the way that business is set up and incentivized, and it's hard because it's like, man, like if we. And there are certainly things we could do better. We could be communicating more effectively with our clients and our prospective clients about what we are and where we're going. And I think if we did that, we could get people to buy in and understand, because we've gotten all the people who are here and all of our investors to buy into who we are and what we're doing and why we're doing it, right? Yeah, it's just about doing a better job of communicating. But when you're a small startup and you got a bunch of people, and in some cases a bunch of kids who have just never had these experiences before, and you have a bunch of people, generally speaking, who are way overworked and overtaxed, the last thing that you're thinking about is how do we better communicate future-based things. Yeah, well, yeah, be truthful, but it's the protection against potential future harm that we don't do enough communicating against, because in many ways you operate in fire mode, because like you wait till there's an emergency before you respond, because you don't have any other resources to look forward to try and stop the fire from happening to begin with, right? You're just trying to get out of the fire that's right behind your butt, which is like the end of your funding line, right? And so if you can't outpace that, if you can't outrun that, if you're doing too much of, and this is what I was talking about earlier, if you're doing too much of looking a year in advance to like where the problem is, you'll never make it there. Because you'll spend so much time trying to shore up that year in advance that you'll make it 6 months and you're dead as a company, right? And so that's why we don't do that. That's why we have to focus very short term. Yeah. It's all craziness. There is a method to the madness, so I'm trying to communicate that to you guys the best as I can. But all right. Did everybody read the Carter Racing case? You have to get out of here at 1. Okay. So we'll do that at like 11:30. Today, I just want to do a couple things. The first is I want to talk about Stencil a bit to get you guys familiar with that and what it is. So everybody read the Stencil docs? Mm-hmm. Okay. Do it again. Okay. After this conversation, because hopefully it'll help make things a little bit clearer. I'm going to talk very high level overview stuff today. Like I probably won't even go like show anything up there. I'm just going to talk about some things. And then read back through that stuff again, especially over the weekend. Try and set up an initial app over the weekend. When you come in on Monday, have created one component. It could be very simple. It could just be like the Hello World thing. You messed around with it a little bit, but just so you have some idea of what's happening there. And then we will get deep into it next week. By the time we finish next week, we're going to be at the point where you guys have all the tools. You should have all the tools to be able to build a real web app, except for the deployment piece. So then we'll start on the projects, and we'll move from there, which I think I mentioned previously. But okay, so Stencil, what is it?
Front-end framework.
Yep.
Was it not technically a framework? It's like a web component.
Yeah.
They say that a lot. It's
Mm-hmm.
not framework. It's not framework.
Mm-hmm.
But it kind of is, but it's not.
Yeah, kind of is, but it's not. So I'm gonna talk through some history for you guys. I do this every once in a while on things, but I think it's useful to put things into perspective and context. And basically, I'm gonna give you the history of my coding. So. When I started coding way back in 2007, what existed was vanilla JavaScript. Technically, jQuery existed, but nobody was really using it yet. It was not a thing that was heard of. JavaScript hadn't been around all that long either, honestly. JavaScript came out in 2001, something like that, as part of Netscape Navigator, which I talked about a little bit before in here. The JavaScript lets you make manipulations to the page and lets the browser actually execute some code. It's not just static anymore. Now we can move things around on the page, and we can maybe make some requests without having to reload the page entirely. jQuery comes out, and its basic function is to make a lot of the JavaScript code a lot simpler to write. So with this $sign syntax, if you go play with jQuery, you can access any of the DOM nodes by just going $, hashtag, some name, and that'll get any elements on the page that are called ID, and things just kind of work the way you expect them to. You don't have to have a very deep understanding of how JavaScript works to start doing DOM manipulation. And they made this HTTP request stuff, this XHR request stuff, this HTTP stuff that's happening behind the scenes and not having to reload the entire page of HTML a lot simpler, because they made $.post and you put the URL in, very much like how Fetch largely took its design and its API from what jQuery did with AJAX request. Okay, so they had $.post, and that made all of that a lot easier. All right. So once you start to do that, now you can start to move a lot of the code that you were previously putting on the back end to the front end. So you no longer have to send some data up, manipulate all the HTML on the back end and the server, and then send down the final HTML product to the page. Now you want to do a lot of that stuff on the front end. And there are several reasons for that. One is you don't have to tax your server as much, because a lot of the times the changes that are being made don't even require a data change to the server. They're just like local changes. So for example, if I want to hide a set of fields on a form until you toggle that something is true, then I can do that just on the front end. I don't have to make any requests back to the server. Okay. So the other thing that had happened is you had a whole lot of there was a separation between back-end coders and front-end coders, which I don't know. Some of that still exists, but that's going away now. And that was largely because the back-end coder's responsibility was to make everything, that full final HTML product, come down, and then the front-end coder's job was to make it look pretty. So all they were doing was manipulating the final product of the HTML, and they did that with jQuery or with CSS. But what starts to happen is as we can move more of that onto the front end because of jQuery and JavaScript, and you can actually start making those manipulations on your own, and you want to put more business logic on the front end of things. Now designers, it's too complicated for them. So now you need computer scientists to be on the front end too. And once we've talked about this, right, and we're doing this actually in these classes, once you understand a concept and a framework, certainly once you understand two languages and frameworks, moving to another one is no big deal. So computer scientists started to take those jobs back because they were like, well, whatever, I can just switch back and forth between the back end and the front end. It's all the same. As that happened, as more computer scientists moved on to the front end again and started to think about, well, how do we build a lot of business logic to happen on the front end of things, they started to say, well, we need better frameworks. I like Java, and I like Rails, and I like the way those things work, and they make my life a whole lot easier, so I want to be able to do that on the front end as well, and how do I do that? And the way that you do that is by developing new frameworks for the front end that let JavaScript work. So there was a big, this is 2010-ish, 2010 to 2014, yeah, somewhere around there. You have this big competition essentially in the space for what is the front end framework going to be. And you've got things like Knockout.js, you've got Backbone.js, and as part of those, you have Angular and you have React. Those two largely become dominant. They take over the field. Everybody ends up doing those. And they start to say, okay, this is what modern JavaScript frameworks look like. Both of them take this approach of components. And they do that because they can see into the future, and Webpack is this thing that starts to come around, and this idea of shadow DOM and of web components. And this is starting to happen because now real computer scientists are thinking about the front end in the right way, and they're starting to see, well, hey, my browser has this component that exists that's image, and I can give it a source, and it just displays an image. And then it has this thing that's H1, and I give it as H1, and it just becomes a bold, large text, right? So they say, well, why can't we just build our own versions of that? Why can't we just make it that we take an HTML tag, whatever we want it to be, and we throw it onto the page, and it becomes some larger set of HTML, right? So that it's simple to use once it's built. So both Angular and React go in that direction, but the design patterns aren't great yet. You have to have a lot of code to make that a reality at the moment, and they try to do a whole lot more than just that piece of it. They're trying to build this whole framework around how do you write code and what does it look like on the front end, especially because you're trying to, for the first time, deal with this concept of like the JavaScript code changes because of a server change or a data change, and now I want to update the front end and I want that to be easy. And Angular does the best job of that. They have this concept of two-way binding where you don't even really have to think about it. There's like this magical thing that just happens that says when my data on a scope variable changes, just change what the HTML is. Okay, and it's beautiful and it's really cool. It has some performance issues, not the most performant in the world, but it does some really cool stuff. React has a similar concept. It's more performant, but it's the same idea, which is data changes, which causes a hook to be called in the JavaScript, which causes the HTML to change, and it just goes back and forth like this. Okay. So now we're starting to move towards, we have this component idea, and we have these frameworks. The frameworks are like a lot. They have a lot of, there's a lot of code that you have to download just to make these component things work, and you have to build in their framework. So you can't just build this component and then say, hey, go drop this on whatever website you have and it's going to work. You have to build inside of their framework, and you have to have that framework loaded before anything will work the way that you want to. Now, what they did start to do in both Angular and React is you could share components within those frameworks. So somebody might build an Angular component, and you could just drop it into your Angular app, or somebody might build a React component, and you could just drop that into your React. So that was awesome, and that's really cool, and that's still, right now, in this world of computer science, that's how most people build. They use React or they use Angular. They build components, they share them inside of the apps. Both Angular and React have moved much more towards modularization, building like little small pieces, and you can just load a very core framework and use that, so you don't have all the extra crap that used to be there that made things less performant. But you still have to, in both cases, build inside of the app. Angular is getting real close to that not being true. Angular just made some announcements in the last few weeks saying we're moving towards essentially what Stencil does, and we're going to talk about what Stencil does exactly and why it's so cool. But they basically said we're moving in that direction as well. And they've been trying to get there for a long time, but it's hard to like change patterns and designs. Well, and it's also like a long time. Angular has existed since like, I don't know, 2010. It hasn't been that long, really. Angular 2 has only existed for the last 4 years, so like it's, it is fast moving. It's just not fast relative to other technologies. So the concept was more and more, let's build this HTML element. I can drop it in, and it's just going to work. The frameworks made it hard, and made it hard to share between frameworks. What Stencil does, and this is why Stencil claims it's not a framework, Stencil is a build process. And what I mean by that is what Stencil does the best is it takes the code that you've written and it compiles it down into a very small, uglified, compacted JavaScript and HTML and CSS set that you can then bring into any website anywhere, because it's pure JavaScript, pure HTML, pure CSS, doesn't require any other frameworks. And you can just drop the component in and it's just going to work the way you expect it to. Okay. So the thing that they're saying they don't have a framework is that they're framework agnostic. They actually do have frameworks, and so you usually use the Stencil framework, which we'll talk about the pieces of that in a moment. But you could build Stencil components in Angular or in React or whatever. But the thing that makes Stencil cool is not that. It's not the framework itself. The framework itself is largely just React, and we'll talk about some of the similarities that they have. What's cool about Stencil is the build process. So it turns it into this pure JavaScript, pure HTML, pure CSS that you can drop into any website, and as one line, you just say script source equals whatever the JavaScript ending compiled file is, and then you put in your HTML component, whatever it is, and it just works, and it just does the stuff you expect it to, and it's freaking beautiful. And you can drop that component into an Angular app, because it doesn't matter, because it's just like any other HTML component. It doesn't know that it's like a different thing. Stencil takes care of all of that. And basically the way it does that is that it's a really simple idea. Like all it's really doing is saying go find a HTML tag on the page, so document.querySelector, name of the HTML element, and then apply this code that we've compiled up for it and run that. Okay, it's a very simple idea, but they were the first to really do it well in terms of creating the components. It's very early stages. This thing just came out of beta in June. We've been building on it. I started building on it in February, March.
This year?
Yeah. It's been around, and that was in a very beta form. It's been around for 2 years now, I think, in total, like development against it.
Did you have any issues?
Oh yeah, tons of issues. That's one of the things you'll find here. We like to stay at the forefront of the technology because you get a lot of benefits, but it means the learning curve is very steep. There's very little documentation, and there's always problems. I mean, there were problems up to we've locked the version of both Ionic and Stencil now in the last month because they introduced a bug that just broke everything. They've fixed it since, and I just haven't taken the time to go update everything back to the right version. But like, it's still not in. I mean, it hasn't been around that long. It's not that stable. It's code, right? And people are contributing to it, and they're contributing still to relatively core pieces of the package, and it's causing things to break. But if you can keep it locked, we're all good. So
A replacement to Angular React, or
not necessarily, but it probably will be, and so I'm going to talk through a little bit of why that's the case. So the component infrastructure, again, you can run it in any framework. So you could build Angular stuff and React stuff or Vue stuff, which is the new kid on the block, whatever you want, and compile it into a component using Stencil. So Stencil can take all of those things and make them pure JavaScript, pure HTML, pure CSS that you can then put onto a website. It's awesome. So that's not necessarily a replacement in that sense. The reason why it largely becomes a replacement is because the way that they've written the language takes the best practices, the framework takes the best practices of React and Angular, and they've done it their own way, and it's really cool, and it's very simple and super performant. So it becomes a replacement. It doesn't need to become a replacement, but it just does because it's really good at what it does. We're going to talk through what the different components of its framework are. And then there's a second piece to it, which is, so Stencil as a framework uses TypeScript. You don't technically have to write it in TypeScript. TypeScript compiles into JavaScript already. So they just did that because it's a little bit nicer. That's part of what's happened here too in the maturity of these frameworks is JavaScript/TypeScript have caught up to make the language a much nicer thing to use than what they used to have. But so that aside, we have something that's pretty nice that takes a lot of the good concepts from both Angular and React that we can start to move forward with. Aside from that, there is the Ionic framework. The Ionic framework was initially created to be a nice version of PhoneGap or Cordova, they used to be called, which is to say it was supposed to give you a way of writing HTML, CSS, and JavaScript and turning that into a mobile app. They would build to both iOS and Android. The advantage of these things was you only have to hire one set of developers. So even at the last place that we worked, where Full Measure used to be, we shared an office space with a company called Social Radar, which Social Radar started like a year before Full Measure did. And because of the time period that they started and what they wanted to do, they had web developers, iOS developers, and Android developers. And they were all different people because they had all spent time in different frameworks. Now, honestly, people should have been able to jump around, but they didn't. And that sucks because that means you're spending 3 times as much money all the way around, both in terms of the developers that you're that you're paying a salary. Yeah. But also the dollars that you have to spend on product development and UX design and all that, because it's slightly different for Android and web and for iOS. So what this Ionic stuff was supposed to give you was a nice way of building apps that would build to any of those things, and that's largely how it was used, and that's what we used it for initially. We built Ionic apps also when it sort of first came out. It hadn't been around that long. We were probably one of the first companies really to be building in Ionic and Ionic only. There were concerns at the time, even when I first started here, performance, that it was going to be slow, that it wasn't going to be able to catch up with the native speed of the native free written apps. But since then, the hardware has advanced so much. Like, it is completely unnoticeable. You have no idea that you're in an Ionic app or you're in a iOS, pure iOS app. I mean, maybe for building games or something, but you wouldn't use this to do that. So that's how they started, and we've been using them for a long time. Ionic initially used Angular as its framework, and then as they moved into Ionic 2, they started using TypeScript because they started using Angular 2. And it was during that time that the React started to catch up and React Native was taking off, and a lot of people were learning React. And they were like, oh, we want to be able to do it that way too. Plus, like, there's got to be some better way of writing this stuff that doesn't require a framework. Like, there's got to be a framework agnostic way. So they started Stencil. They started building everything in Stencil, and they started to split. So now there is still Ionic. My guess is Ionic is going to become pieces, and it already largely has. But there's the CSS framework, which we'll talk about in a second. There's the Stencil framework, which does the distribution and creation of the JavaScript, HTML, and CSS. And then there's what's called Capacitor, which is the thing that takes the JavaScript, the HTML, and CSS, compiles it into, it's essentially, I mean, largely it's just a browser that doesn't have a URL bar or tabs, and then makes a browser that looks like your app, has the logo, etc., and then runs the HTML, CSS, and JavaScript that you've created. Okay, that's all Ionic originally did. That's what PhoneGap did. And then there's things called Cordova plugins, which allow you to access native functionality of the phone. So you can then, from JavaScript, get hooks that access the camera from the phone, or the GPS locator, or the Bluetooth, or whatever QR code scanner, whatever you want to use that's natively available. So there's three different pieces. Again, Ionic built its own version of Cordova called Capacitor. That's the thing that actually builds an app from website technologies. There is the Ionic framework, which is the CSS, and then there's Stencil, which does the componentization of things. Now, during this historical setup that I've brought about, we started to move from, you have iOS and you have Android and you have web, to this concept of progressive web apps, PWAs, which you've probably heard a little bit about. But basically it's this idea that now that the web technologies have caught up and a lot more people are using technologies like Ionic, let's just make apps from websites. Like, we don't need 3 different languages and 3 different frameworks. Let's just do it all together. And we even noticed this late. We should have just done this. It should have been obvious, but it wasn't. We did notice it before Ionic started talking about it. But so you'll notice if you go look at the Ionic app that we have currently, that we initially completed in 2015. That app, we then needed to have an HTML, a website version of that. And what we really should have done is we should have just built the thing as a website and made it mobile responsive from the beginning, because it runs on the web just fine. But because of the way Ionic promoted itself and everybody's schemas of how things work, we didn't realize, I mean, we kind of did, but we were like, that doesn't make any sense. We didn't realize how easy it would be to just drop this thing as a website and an app at the same time. So we spent 4 months of development time doing nothing but recreating the stuff that already existed in our Ionic mobile app that was already a web technology, and recreating it on the web in a different way. It wasted a bunch of time. Okay. Less time than people who had to build for iOS and Android and web, because we only had to build for iOS, Android, and web, right? But still wasted a bunch of time. These PWAs, that's where life and computer science seems to be going. And so that's what we've been building in these beta technologies now. But it combines these 3 pieces. You have a CSS framework, a way to build it as an app, and a way to take the components and use them on the web in some way. All right. Ionic is a CSS framework. There have for a long time been several CSS frameworks that have been coming out to help developers make life easier in terms of implementing standardized, beautiful things. When I first started, there was nothing like this. You just had to know a bunch of CSS, and you just had to sit there for a lot of time and tweak things and get things just right. Bootstrap, and then Foundation, which was a similar but less popular model, came out and like dominated the industry. And it was basically like, here is more or less Google's material design concepts, and here's the components that will just build it. All you have to do is put the class on the button, and it turns into a pretty button, and you're good to go. Right? You don't have to think about UX as a developer now. You can just drop these components in, and it works. The Ionic framework, the CSS framework, is very much that. It's just a bunch of nice components that are built in Stencil, so they can do more functionality than just the CSS, which is a little nicer. So you can like slide to the left, and you get your buttons on the left-hand side, and click on it on a phone, and you can pop up your modals, and you can do all that kind of stuff. But largely, it's just a CSS framework. It's just a way of getting nice, pretty things without having to do a lot of CSS work. The way that we build here, you should never really have to do CSS. If you're doing real CSS, you're probably doing something wrong. And the reason is that the way that our designer does things is he looks at what Ionic's components are, and he will just tweak them. So he'll give them like a different color or place them in a different spot or that type of thing. It is far less like we're going to have our own custom components for every single thing. There's a massive advantage in doing it that way because you could speed up development really quickly in terms of both the communication, because I don't have to go ask him exactly how many pixels is the thing away from the edge of the screen. I can just know that Ionic's ion item will put it that far away. But it also makes it a little bit easier for him because it constrains him within a certain context. Now that we have Stencil, we actually might go back and create our own custom components at some point, but that's a future thing because it's easy enough to do now. All right, so that's that piece of it. The Ionic as an app creator, the capacitor piece, we will probably not get to that during the internship. You'll probably learn that if you continue to stay on the job. We'll go over it probably for one of the instruction days, but we won't. It's harder than it looks because it's still not a great technology. And honestly, the hardest part of all of it is the way the Google Play Store and particularly the Apple Store are set up. They just make it really hard to put something up on the store. Mostly, I think, because they were built and hacked together. Much like we had to build the messaging app, the in-app messaging, in 3 weeks. I think Steve Jobs was like, "You're going to build this app store in the next 3 weeks," and they kind of just threw the thing together. And because there was nothing else out there, but they wanted to compete and they wanted to have it at their opening. But as a result of that, there's a lot of bugs and leftover like overhead that's not great, etc. From way back when the App Store came out, 2007.
Technical debt.
Yeah, technical debt. And they just haven't done a revamped version because that's also a huge pain when you have millions of apps that are up on your store. So
App Store 2.0.
App Store
Download,
2.0.
go to the App Store.
Yeah, I think more likely the original App Store, and then you go from there. I think more likely what's going to happen is we're going to move towards like PWA listings, and there's going to be a whole different marketplace, and that's probably going to change a lot. Yeah, because PWA is, you can essentially just list like a link, and it will just take you there, and you can download it. Fortnite tried this not so successfully about a year ago to try and avoid the fees. So Apple, for example, any in-app purchase that is made through Apple, including like Amazon purchases of physical things, it's a 30% overhead cost to the producer. So if we created something and we sold something, it's massive percentage when they do literally zero things.
You're just selling it on
You're just selling it. Yeah, but then you're not even selling it on their platform. All you're really doing is placing the access to your platform on their platform. All it is a link through to a thing that you're actually, it's your thing. It's being hosted on their phone, not on the App Store, right?
30% is huge.
30%, yeah. So, we're not going to sell anything on the App Store. We won't make any money if we do that. So anyway, I think that's going to be changing. All right. Going back to Stencil and what it is in terms of its framework aspect, it is very much like React. So,
I'm going to close the door.
Oh, yeah. There's a couple decorators. Does anybody understand what decorators are?
It's basically just like It's you have like usually have like an app sign, and then you have some whatever the name of the decorator is, and that goes like in front of a variable or a function, and it kind of instructs the compiler to do something special with it.
Yeah.
Sort of.
Yeah, that's fine. There's a very real technical interestingness to decorators, but it's too technical and stuff. So for now, we're gonna say decorators are these magic things that do magic things. And it's because it's beautiful. Because if you just believe that, if you just trust that, they do really awesome things. And that's part of what you're gonna have to start to incorporate in your own mindset as developers anyway. We talked about this a little bit before, but you can't go super deep. You can't understand everything down to the byte level. At some point, you have to trust, because otherwise you won't ever get any work done. Okay. So we're just going to trust this thing. If you're interested, we can have conversations about them in more depth later. But there's a few of these that are important. There's state. There's prop. There is event. There's listen. There's method. We're just going to stick with these two. These, you will probably use these at some point. This one you may never use. When you're working in Stencil, and if you just set up the default app, it's going to create a couple components for you, and that should be relatively obvious. The thing that matters in the component is the tag name. The tag name is just a reference to the HTML component. So if you name the tag like full measure chat, and then you let Stencil do its compilation stuff, you can go to any website that's yours, and you can say script source equals app.js, and then you could do full measure chat, and you may have some attributes that you put on there, maybe not, and then your whole web chat component pops up and works and does all kinds of beautiful things. Okay. Each component will have a tag name. Full measure chat would be the tag name for this, and then you can have components inside of there in the HTML and that sort of thing. That more or less probably makes sense. Like when you're looking at the code, there's a function called render. Render has the HTML in it. That's what gets rendered when you load up a page that has that component on it.
So if I was like building like a total like my app,
Yeah.
how would I drop that into my app? Like how does that?
That's literally, so you can do it in a couple different ways. You can host your JavaScript on a CDN, they're called, Cloud Distributed Network. You could host it on your own website somewhere. There just has to be somewhere. So you'd say https://ben.com/app.js, and so long as app.js existed up on that server at that location, it would get pulled down onto the website that you were trying to use it on, and then they just have to do full measure -chat, and it would just work. So it's just like how you include jQuery in your code. You could also just as easily do an npm install of the code and then reference it that way. So it's the same as jQuery or any other third-party JavaScript library that you would be using. It is available because you now have the app.js file locally on your client on your computer, and then you can reference any components that are by just referencing them. So there's a render function. Again, render, and this is important. So there's a render function, and that just says when I load full measure chat. So here, I have a tag. It's called full measure chat. And then I have a render function, and maybe that just says h1 under construction. And so if I have a component like this, and I've done the stencil build, it's created my app.js file, which I can then include anywhere on a different website, on my stencil projects website, whatever, index.html file, whatever. And I have full measure chat. It's going to replace full measure chat with h1 under construction h1. Okay. So whatever's in render is going to replace whatever the tag name, wherever the tag name is. It doesn't actually replace it. What it really does is it puts it inside of it. Okay. So, simple things. When you generate the app, you're going to see this. When you go to generate your stencil component, it's going to have already, and you're going to want to choose PWA, we'll make one, but it's going to automatically create a component that's going to have a tag that's like app-home, and it's going to have a render function that's going to do something like this. And when you go look at it, it's when you go look at the index.html, it's going to have something like app-home, and you're going to see that if you load that page up, it's going to do something like this. All right. So that's the render component. Then there's state and there's prop. Let's talk about prop first. Prop is a way of passing data from one component down to another component. Okay. So for example, I have this full measure chat component. Maybe I have another component that's called full measure header. And so in my full measure chat, maybe all that I render is full measure header, and maybe it has an attribute of text, and I set that equal to under construction. Okay. And if I go look at that full measure header, it's going to have a tag with full measure header. It's going to have a render function, and maybe its render function is just h1 this.text. Okay. What it's going to do is replace text, and so we're going to end up with exactly the same thing. And we'll go build this in just a second so you see what okay. But the point is, there's only a few things that you need to worry about at the moment. There's a tag that tags a reference to what the HTML element is going to be called. There's a render. That render function is what the HTML is going to get rendered. What you might render is another component that you built in Stencil. That other component can have what are called properties, or attributes. In this case, it's text. And text is then going to get passed into full measure header, and you can then use that inside of the subcomponent. So there's a way to, and just kind of follow me now, and we'll go do it in just a second, but there is a way to pass data down into other stencil components that you're creating. And you do that with properties. State is a little different. State is within the context of the component that you're using. State works, if you're familiar with React, in the very similar way that state would work in React. It also works in a very similar way to that in Angular 2 this would work, or in Angular 1 scope would work. Which is to say, when a state-based variable changes, it will recall the render function. Render gets called again. It does it in a smart way. It does like React, so it only repaints the things that have actually changed. It doesn't change everything, so it's just performantly, it's more performant. But when you're thinking about it, if you have a state attribute or a state variable that you've created, anytime that state variable changes, the render function is going to get called again. So that's how you update your HTML. So you could say something like, when somebody clicks on a button, then I want the button clicked variable to change from false to true. And when that happens, we'll call the render function again. And that time you might check to see if the button clicked is true. And if it is, maybe you show or hide something.
So if you're building like the to-do list we did, you put like the list in the state, not props.
Yep.
Yep.
But in the props, what you might be passing down is like the ID of that particular to-do list item. So maybe in the highest level, you have your to-do list, and then inside of there, you have to-do list items. Each to-do list item would have an ID of the one that you're trying to show. We'll actually build a to-do list, though. Probably not today, but next time. But I want to show you guys really quickly just a very basic stencil app to try and get these two concepts a little bit more clear, and then we'll go to how to do this. All right. So does anybody know how to initialize a new stencil project?
Stencil in it.
Yeah.
Init stencil.
Pretty close.
npm init.
Yep. npm init stencil. After you have stencil installed, you just do npm init stencil. Three options come up. Just to talk through what these three options mean and then tell you what you should always do. It tells you, but I don't know how clear any of this is. A component is it would generally be a very simple single component. You just want one of them. You don't want any of the Ionic Framework CSS stuff. You don't want to potentially turn this into an app that goes onto a mobile device. You just want a very simple component. In many cases, so like a great use case for this would be like a web chat widget. So like you've seen, I always forget the name of the company, but they have like the chat bubble down on the bottom right, and you see the same chat bubble looking thing on lots of websites. That is a great opportunity for a component because it's this very small thing that you just want to use inside of other apps. Okay, so that's what a component is. An app would be, okay, I want to build a website. I want it to do more than just that one little thing. I want it to be an encompassing thing, but I don't want the Ionic framework, and I don't want to make this thing go inside of a mobile app, right? I just want a website. I just want to build a basic website. Maybe I want to use Bootstrap. I don't want to use Ionic, or I want to do my own custom thing. I just want a website. So that's minimum starter for that. We always use this because it's dumb. Because you can do all the other things. The only disadvantage is that if you literally didn't want to use the Ionic stuff, these will load a little bit faster. This one honestly, and this one, the difference has got to be like nanoseconds of performance. I don't even know why they make this as two options. Okay. And all this one does is add the Ionic framework, which is like, I don't know, a millisecond of loading the data. So I honestly don't even know why they do it. They probably will take care of it eventually. But always choose Ionic PWA, and that way you start off in the right place and you can use all the Ionic stuff. It's awesome. Boom. And then we're going to name it my first stencil or something. Sure. All right. It tells you what to do. So we can go inside of my first stencil. And we're going to say npm start. And everything's broken. I don't know. Did it say to do npm install?
I wouldn't imagine what you had.
Well, so you don't have anything installed, including stencil, until you do npm install. I don't know why that's not in the instructions, but you have to do npm install.
You have to do it every time you create a new project?
Every time you create a new project, or you'll see, we don't, for Git, you never send the node modules folder up to Git. And by default, they Git ignore it. And the reason is it's all these third-party packages that are relatively large and that likely change between you using it and me using it. And because the package.json tells us what you need to be able to run this, you don't actually need to store it on Git. You can always just pull it down from npm. So you can keep your resources cheaper on Git and still share these things around, and pulling them up and down is faster, and you just use node modules locally. So anyway, so this is a very common way of doing this. When you're using third-party packages, you use npm install. You only have to do that like the first time, or if your package.json changes, you'll be told if that happens. So it's all good. But here we go. Very simple. So we have this app.home. We're going to go through what that looks like. My first stencil. All right, there's not too much you're going to play around with outside of what's inside of the source folder. Just to give you a little bit of background on what the other things are, this .stencil directory is part of the build system they do. Never want to go inside of there. Don't ever touch it. Node modules is your third-party packages that we downloaded when we did npm install. So we got a few things. We got like Ionic and Stencil and Ionicons and a couple other things. Don't really ever want to go inside of there. It's just where the things go. www is when you do npm start, it builds everything, compiles everything from TypeScript and CSS into pure JavaScript. And so that's what's inside the www. Also don't want to ever touch that. Editor config is just trying to help RubyMine do things. Gitignore is your gitignore file, like in other places, license. Package.json says what things you need to install. It also has the commands that are already set up for doing like the stencil build and serving things and all of that. They're just shortcuts, really. Package.lock.json is just another version. It's just like the gemfile.lock. README is just a README file. Stencil config, we'll want to mess with this a little bit. We'll talk about that later. For now, you can just leave all the defaults in. It's all good. And that's pretty much it. So the only things you'll ever really interact with are stencil.config, and probably only one time per project setup, and then inside of source. Okay, so very much like with Rails, you do everything inside of app. With a stencil, you do everything inside of source. All right. So there's a few components that they've set up for us. The rules with stencil are you want to have one component per directory, and that allows you to put like your test and your JavaScript and your CSS files and stuff all in one place. So all 5 of these things that are related to home go in one place. And most of the code is in the TSX file. TSX is TypeScript X, XML. It's taken from React. React has what's called JSX. It really just means we write our HTML inside the JavaScript. That's all. Used to be that you would write the HTML in a different file than you write your JavaScript in. Now that everything's becoming componentized, we put all together. All right. So like I said before, we have a couple things going on here. So we have @component. This is one of those decorators. It's saying that the class app home is going to create a new stencil component with a tag of app home, and then a style URL of apphome.css, which has nothing in it right now. So this is just the CSS file to go with the component. We don't have anything in it. You technically very easily could just, boom, just to make it simple. You don't need it. You're not using it for anything. All right. And then all it has is a render function. So this code does nothing except say anywhere that you see app-home in my HTML, will put inside of that this stuff. Okay. Most of these things that you're not familiar with, all these ion dash things, are from the Ionic framework. So you can go look at that documentation, read through that. But it's very simple. It's just creating nice, pretty headers and content and stuff for you. Okay. All right, so if we go serve this, we go look at what this actually looks like. It looks like this. So we have our header that has home, and we have this stuff, right? And if we go look, there's a little bit more going on here. If we look at the index.html, which is what's actually serving, this is the index.html that's serving this, we can see a couple things. One is that we have a script file, 2 of them actually, that references build app.js. When Stencil does the compiling of all the TypeScript and the HTML and CSS into something, it moves them into a file that's in your build directory's app.js file. There's 2 versions of it. One's ESM, one's not ESM. It's really just ESM is the new stuff, the new. The non-ESM is old JavaScript. It's old plain JavaScript with some patches and stuff to make it work. But your browser will only ever use one or the other. And the way it knows is by using this type equals module or no module. So it only uses one or the other. Okay. You don't have to worry about that all that much. Just know that the TypeScript is getting compiled down to a JS file, just like the JS files we've been playing with on our own. And that's what's getting pulled in. And then you see there's this one component in our body, which is app root. App root actually references app root, which does some things for routing. Eventually you guys are going to start using our routing. You can build your own router, but for the moment you can use this. It's pretty straightforward the way it works. So it's just a component that has, you put ion route and then the URL path and then the component that you want to load. And the way this works is that when you go to, in our case, localhost 3333 / it's going to load onto the page a component that has a tag of app-home. And if you go to the URL localhost 3333 /profile / some parameter name, it'll open up the component app-profile, which is just this other app-profile, which we know because it has that component name. Okay.
So when we're building our own apps, should we not be touching index.html because that has like the root and everything goes in the home? It's like
Yeah. So you generally won't need to touch, especially when you guys first get started. You won't touch index.html. It's just going to work. What you will change is you'll go to app root and like you'll make a new path, like right, and then you'll make your own component called my first component.
So then would we be getting rid of app home then?
You could, or you might keep it and just change it.
Okay.
And then it's whatever you want to do. If you deleted app home, you would delete this, and then you probably need something to go to for your slash.
Okay.
But like
the only way, and this is your routing page.
this is your routing, yeah. So this is very much like the routes.rb file in Rails. It's just that it's in stencil, and you just come in here and you say, if I go to /profile /name, I want you to load the component that has app profile. All right, so if I go inside of app home, nothing's really happening here. Just to prove that this actually makes changes, I'm just going to put some nonsense in, and then when it reloads, you see, and it auto reloads for you when you change the JavaScript page. RubyMine auto saves when you leave it. You might have noticed that already. But so the fact that I typed something and then I left, it saves the file. When the file's saved, Stencil looks for a change to that file. If there's a change, it updates its stuff. Okay. Every once in a while, you still have to hard refresh the page because it didn't get some change or whatever, but most of the time it just takes care of itself. All right, so that's how that happened. So so that's it. App home affects what it looks like on that page. I can look in the HTML and prove that too. So the router, so if I look inside of body, we see app root there, which we saw on index.html. Inside of that, we see ion app, which we saw when we looked at the app route. If I look inside of ion nav, this is where it ends up placing the component that the route points to. So that slash points to app-home. So it puts app-home here. And then inside of app-home, we have what's inside the render function for app-home. Okay.
So if we created like a component that was form and a component that was list, those two components would go inside of app home's render.
Yeah. So like if I'm inside the render and I just change this, but I could do like, if you wanted to put a form here, nobody actually uses the form tag anymore, but
if we created a new component that was called like my form,
I see. So
then you just throw my form in here and then create the component.
Yeah, so like let's just create.
What do you guys use instead of the form component?
Nothing.
It has this nice report validate thing though, and that's the only reason I use it, because you can do like report validity, and then Ionic will like make this little thing up here that says like, please fill out your name if it's blank or something. Do you guys do that a different way?
Yeah, so that's not Ionic, most likely. You might be using the Ionic form controller, which is a little different.
I think I'm just using the regular form.
So HTML browsers implemented several years ago a way of doing validation that you can use if you click the submit button and things don't match up correctly, but it doesn't look very pretty, so we don't tend to use that. You just do it on your own. You just like the data, we'll get into this more as you start to see the fact that like you have the object completely available to you in the JavaScript code. When you click on a button, you just say go validate the object, which just runs it through an error checker to see if everything's the way that you want it to be. And if it's not, then you render an error on the page, and if it is, then you submit it. It's pretty simple. We'll do that.
Can I watch you create that component again? Because when you you created that component. Didn't all of this like directory come with it?
Yeah, I don't care about any of it. I'm just like deleting. Okay, so all I've done is copied app home to my home, right?
Oh, that's okay.
So like it still says the app home, RubyMine did a thing to auto translate app home here to my home, but that doesn't matter anyway. So like I'm just creating my own. All right, and I'm just gonna.
But when you initialized it, did you copy the entire thing directory?
Yeah, I just copied.
Oh, okay.
I just copied all of this to down there, but I only care about this. So I have my home. Let me go back to app home. I'm just going to replace all the content so we don't have any of this stuff. So what do you guys think is going to happen when I reload the page? Yeah, it's going to say yo, because this is my home, and I have an H1 yo. That's it.
So the more components we add, like we want to put like a graph under there, and then under that we want to put something else. Those are all going to go in app home. Those components.
So yeah, I mean, and then how you split it up, like whether, because you don't have to create new components to do that.
Okay.
You could just keep writing code here.
Okay.
The nice thing about this though is it keeps you pretty small. Like you're thinking in the right way.
Yeah.
Like if I want to do a graph, which is a relatively complex thing, I probably want it to be its own component and then just include the graph. Technically though, you could write your entire app on this one file.
Yeah.
Don't do that. But technically you could, just to
Yeah.
make it clear what's.
So is it like every tag is in your component on Stencil?
Yes and no. So like here so app home is a component just like my home. But you can see there's a header and a content and some information inside of it. My home is very simple, and so it's literally just one tag. But there's no need for that to be the case, and that's what I'm trying to say. You can
just put that into.
Yeah, I mean, I could do the exact same thing that I have accomplished here by just doing that. Right? It does the exact same thing. The usefulness of putting it in my own component is that as it becomes more complex, so like if it was a chart component and not just something that said yo, then pulling it out makes it a smaller amount of code that I'm looking at any particular time, and I can potentially reuse it all over the place. And I can pass properties into it, which is what I'm going to get to in just a second, that helps me to be able to do that more easily.
Can
So-
you change it back to my home and then put yo inside of that? Put yo right there.
No, you can't. There is what's called slots that you can use. I don't want to talk about that right now, but there's a way to do that. Here's what we're going to do instead. I'm going to talk about properties. So I'm going to create an app prop on my home that's called text. So we have to import it. I'll talk about those things in just a second. I'm just going to call it text. It's going to be some string, be whatever we want. And then down here, I'm just going to reference this .string.
So text is a variable name and string is the type.
Sorry, the wrong way. Text. Text is the variable name, string is the type.
And you have to do that on these props.
You can do any, which is saying it can be anything.
Just TypeScript.
It's type. So TypeScript forces you to have a type, but technically that type can be any, and any can be anything. So you can
It
go
has to be
back.
some type.
It has to be some type, but some type might be any, and any can be anything. All right. Depending on how your TS lint is set up, RubyMine may or may not complain. Like the way that this one happens to be set up, you don't have to do that. You could just do this. It's better to do that though, because if I leave it as string, it gives us some nice properties. There's a reason why typing exists and why people like to use it. And the biggest is like here now, I can put a property here called text, and if I put 4, it's going to yell at me. And it says, no, type number is not assignable to string. That's useful, because when I'm using it somewhere else, I don't have to go look up the definition and how it's used in the other code. I can just get from right here. Oh, I need to put a string. Cool. I like strings. That makes sense. It's text. Right? And now what do you think is going to happen if I reload?
Replaced.
What's replaced?
The yo.
The yo.
Yeah, what's yo going to say?
Hello world.
Yeah.
That's because yo was a property.
Yeah,
That
so-
can be manipulated.
So text is a property on my home, at prop that we've named. It's of a string type, and I can pass anything I want to it into it from any higher level component that's using my home. So app home is using my home. We can set the text attribute to be hello world, and then inside of my home, because there's that text property there, I can say this.text, and it'll put whatever the text was that they sent down. You can put as many properties as you want.
Oh, so yo wasn't even replaced like I
It
said.
wasn't even there.
It was
not even-
set.
it's set.
You just said it.
So
Oh,
there-
well then, yeah, you should definitely all be properties because, like,
so I can say like name Sam, and now it'll say hello world Sam. Okay, so you can have as many properties as you want.
So why is app home a child of my home?
It's not.
Isn't that the whole prop thing that was passed down?
So it's passing down. So app home is a parent of my home, but only in the sense that app home uses my home. Okay. So if we follow this all the way back through, so let's just start from the beginning. Localhost 333 / what's that going to do? I don't know. Let's go look at index.html. Well, index.html, so / should load index.html because we've talked about that. It's going to load app root. Okay, given a little bit of what we know, I'm going to skip over this, but a little bit of what we know about Stencil, I should probably go look for a component called app-root. Okay, cool. So let's go look at that. App-root, we're here. Okay, remember, I'm at localhost 333 /. So what's that going to do?
Look at app.
So that's going to load a component called app home, given the little bit that I know about Stencil. So I'm going to go find app home. And I know a lot of this is magic, but this is it's easy magic. Like it's obvious magic, like in the sense that I can follow it and it makes sense what's happening. So I'm going to go inside of app home, and inside of app home, I see, okay, well, that's going to call the render function, which we talked about. Render is going to return an ion header that says home and some nonsense. And then it's going to render an ion content, and inside of that, it's going to render my home. So then it's going to pass into my home a name property and a text property. The name property is set to Sam, the text property is set to hello world. And if I go inside of my home, I can see there's a text property and a name property, and that's going to render h1, this text, this name. So my home is a child of app home in the sense that app home renders my home.
So it has nothing to do with like file structure. It's just
Nothing to do with file structure, just usage. But you can pass data down from app home to my home.
What is the point?
Any of this?
Like I just why is it
Why is this?
why is there so much like rerouting from the different
So we're using a very simple contrived case here, right? The place where this starts to become more obvious is like where you might have a particular item, like you have a list of things, and each thing in the list is a card, let's say. Each card has 10 pieces of information on it. I can either try and make all of those 10 pieces of information happen inside of app home by writing all the code here, and then eventually, very quickly actually, this becomes like a 200-line file. Or I can take that item and I can move it out, and when I loop over the list, I'm just going to say make an item for each one of these things in the list. So like, let's say, here we can create an instance variable that's just called people.
So it's an instance variable, even though you didn't use that. We don't use that here, so that's Ruby.
Right.
You need this dot people?
When you use it, but not when you declare
Okay.
it. So now I might do something like render people. You do interpolation in Stencil with these curly brace things. Then I can create a function called render people. Render people is going to return this dot people dot map person return
Just start under people.
it's a comment on dot. Okay. All right. So I have people. It's this instance variable that I've declared, and it's initialized to be two people, one named Sam Birk, one named Josh Birk. And then so then I'm going to call my render function. That's the first thing we're going to do. Render is going to return a header, and then it's going to return content. Inside the content, it's going to call render people. So that's going to go up to this function, which is going to say return the result of this map. So I'm going to loop over each person, and for each person, I'm going to change that person. Remember, maps change things. I'm going to change that person into a HTML element ion item with an ion label that's that person's first name and that person's last name. So in other words, I'm going to generate a list that's going to have Sam Birk, Josh Birk.
Does it always render first and then render people?
It's a convention that we use because you can have other real functions that do non-rendering things, and it just helps. We'll talk a little bit about like code structure and why you do these things, but it could have no. It doesn't matter what you call it, as long as they're the same. That would work just as well. Render does matter because render is special and stencil, so you have to have a function called render because that's the first thing that gets called when it loads.
How did you do that fancy thing where you typed in, you changed the name of the method and it changed the usages names?
I just highlighted render people, and then if you press Control G, it'll highlight other instances of the same thing, and you have multiple cursors, and you can.
Oh, that's nice because I always gotta like go down and find all of them and change them.
Yeah.
Does Ruby have it where you
No
can
refactor.
highlight the first one and then it does
Mhm.
subsequent ones instead of all of them?
So it does one at a time.
Yeah.
So if you press Control G, it finds one at
Oh.
a time. In this case, it's only
Oh, I
one.
thought Control G did all of them.
No, there's probably a shortcut to do that,
Maybe it's
but
Command Control G or something.
yeah. But you can also, if you just hold Control G for less than a second, you've probably got all of them.
Oh, okay.
So, yeah. All right. So, yeah. So there I am, Sam Birk and Josh Birk. All right. Now, but you can see this is already starting to get complicated. This is a slightly less contrived example, but it's a little bit bigger. It's getting a little bit complicated. So what I could do instead is I could create a person item component. And just by convention, the naming of this stuff doesn't matter at all. The only thing that matters is the tag name that you use. So like I could name this a blue sky and it wouldn't matter. It's just this that matters.
And you need the
This also doesn't matter. Hyphens, underscores probably work. It's just a convention to use hyphens. So now, instead of having all of this here, I can move it here, which makes this a lot smaller, and then my property is just going to be a person, which is going to be an object. And really, I can be more explicit and say it's going to be an object that has a first name that's a string and a last name that's a string. That's, again, you don't have to do that. That's just helpful. Why don't you like this? Oh, whatever. Okay. All right. All right, so now if I go back to app home, I'm going to loop over each one of these, and instead of having to do that whole set of code, I can just do it's a lot less code. Right? And again, this is a relatively simple example, so I only moved 6 lines into one line and then simplified the other class. But you can imagine how very quickly, when you get more complicated, you're reducing hundreds of lines of code to one line, right? and then even in that 100 line of code, you're reducing it to like 5-10 line things, and it becomes a much more reasonable and reusable thing. So like this person item I'm using here as I loop over it, but maybe I use this person item in 50 other places where I have a list of people, right? It happens to be on the home, but it's also on like the message page or the context search page or the whatever. And so you can reuse those things in all those places, and then you don't have to rewrite the code again. You just pass in person and you're good.
So that person that's in the yellow there, is that the prop?
Is the property, yeah. So in our case, we named it person. That's reference to this. And then what we pass into it is an object in this case instead of a string. So interpolation again is done with the curly braces, which you can just pass the object straight through. And then we're going to get the same result. But now it's less code and it's a little cleaner and all that. So the point of it is to help you to modularize your code, which helps with both readability and reusability. Okay. So that's property, so we're dropping things down. The other thing that you can do is and dash button, and then we'll get into the actual card erasing case. Yo, on click equals toggle show people. I'm gonna do this quick, so don't feel like you need to follow along so much, as I'm just showing some of what you can do here. Show people true. See, so this one doesn't have a render because it's going to be actual functionality. I'm just going to say this dot show people equals not this dot show people. All right. So let's just read through this quickly. So we have two instance variables now. First one's people. Second one, we're going to make a state variable. Still an instance variable, but now it has state on it, which means if it changes, we're going to what?
Re-render.
Render gets called again. Okay, so that's the important thing. So if you put the state decorator on an instance variable, when it changes, render will get called again. Okay. So in our case, we're going to go to render first. Render is going to return home some nonsense. It's then going to go call render people. Render people is going to say if not this dot show people, then return. So what is show people at the moment? True. So is it going to return? No, because this dot show people is true. If not, this dot show people is false. So it's not going to return. So it's going to keep going. So we're going to return our list of people. Okay, and then we're going to render a button that says, something more reasonable. Show hide people. When we click on that, we're going to call toggle show people. Toggle show people is going to change this dot show people to not this dot show people. So this dot show people is true currently. So if we click on the button, what is this dot show people going to become? False. It's going to change because it's a state instance variable that changed. We're going to call render again. Render is going to say, okay, here's our header with home. And we're gonna now we're gonna call render people again. This dot show people is now false, so this dot not this dot show people is true. So we're gonna return. So we're not gonna show the people. So they're gonna go away. Then when you click on the button again, they're gonna come back. Back and forth. There we go.
Nice.
See it? Simple example of state. So that's state and prop. Prop goes through. Also, when props change, the renders of the underlying should also change. But when state changes, it should re-render. Okay. Questions about that?
But the parents don't change, though. It's just the child.
The property, if the property changes, I don't know. We'd have to play with it. Maybe. There's a mutable property. I don't know. I haven't paid enough attention. All right. What I want you guys to do is to pull out the Carter racing case, and I want you to come to the decisions that you're supposed to come to there. Which is basically race or don't race. And then I'll come back in about 25 minutes. And we'll see where we're at.